what determines economic growth, what we should be worry about, or what we should look at when we try to understand what determines economic growth. What we're focusing on today is the economic growth, and growth is basically the steady increase in aggregate output over time, and that means we're shifting our focus from looking at economic fluctuations in the short run, or looking at the medium run, and then now we will look at economic growth. Basically, we are concerned about what is happening in the long run. So we move from what determines output in the short run or in the medium run, which we covered in the previous lectures, to talk more about what would determine the output level in the long run. So when we talk about economic growth, we basically are concerned about the standard of living. And when we talk about growth, we basically looking at output per person, and we compare this over time and between or across different countries. And obviously, because we look at what is happening between different countries, or if you want to make that comparison, then you need to account for differences in price levels and also differences in the exchange rates between different currencies. But what we'll focus about today is basically we look at the growth from the production side, which the measure we use here is the output per worker, or you could look at this as output per hour worked. So before we look at that, we need to understand the production function. I know we've come across the production function before. We discussed different aspects of the production function. We explained that the production function is a relationship between inputs and output. So we on the right hand side we have labor, we have capital, and then that is determined by technology as well, and then how these interact together, or how these enter the production process, what is the output or the production on the left hand side. So this relationship can be summarized as you see now on the screen. So we have y equal if is the function that depends on the state of technology, as I said before, and then you have two inputs in this production function, which is k stands for capital as usual, as we know, and n stands for labor. So if we assume constant return to scale, meaning if you double your inputs, so if you double the amount of capital you use and you double the amount of labor you use, and then after you do that, if what happened to output, that output has been doubled as well, so that's what we call constant return to scale. Okay. However, if you have a decreasing return to scale, means if you double, let's say, the amount of capital, then your output increase by less than the double. So that's what we call decreasing returns to capital. In this case, because I change or I double capital, the amount of capital I'm using, the amount of machines, the amount of capital I'm using, and then what happened is that the output, if output was the double, so that means constant returns to capital, but if the output was less than the double, so that means it's decreasing return to capital. Similarly, when we talk about labor, so decreasing returns to labor means if you, for example, if you double your the amount of labor you use, so if you were using 4 workers and now you change that to 8 workers, so you double that, and then what happened to the output? If the output changed by less than the double, so that means this is a decrease. This production function exhibits decreasing returns to labor. Okay, so why you will see in a moment why we say that, because why we want to understand that, because you will see when we plot the production function how that will translate into the graph and into the slope of that production function. So in this way, so now let's just look at the, rather than looking at the output level, we will look at the output per worker. As we said before, this is kind of the measure we will look at. So when we look at output per worker, and in that case we just divide this production function both sides by n, or the number of labor. So that means y over n equal f, which is, as I said, this is a function that depends on the state of technology, which we'll take as given now. So we're not going to assume that there's any change in technology. So technology now is constant, and then maybe at the end of the lecture we'll see what would happen when that changed. But for now, this is something, let's assume, is not going to change. And dividing the right hand side by n, or the number of labor, so that give us capital per worker, so k over n, and n over n, which is basically 1. So going back to the idea now of a production function, which we actually I think we plot before production function when we try to drive the aggregate supply curve from the equilibrium in the labor market. We show that how the equilibrium labor market lead us to, or show us where we are in the output in relation, which is the production function. That how we use that, use the 45-degree line as a mirror to again to see the combination between P and Y, or the price level and the output level. So we've seen the production function before. It's not the first time we talk about the production function, but we need to go back to this today just to explain this in a little bit more details. And also we want to know about what can determine, or what determines economic growth in this case. So increases in capital per worker, that means we moving along the production function, just given that in this case we will have capital in the horizontal axis, so measured in the horizontal axis, and output level Y measured on the vertical axis. So any changes in capital per worker, that means we actually moving along the same production function. But if technology, or the state of technology has changed, so that means that should shift the production, or the entire production function output, the entire production function upward, if there was an improvement in the state of technology, or if there was an adverse technology shock, or whatever happened to technology that became worse for whatever reason. So that means the entire production function should shift downward. So now, from what we said now, so that means economic growth, or as we said, the measure we were looking at here is the output per worker. So for that to grow, for that to change over time, we could look at the capital accumulation and technological progress. So basically, when we talk about capital accumulation, we're looking at a higher saving rate. When we talk about technological progress, we are referring to an improvement in technology. So now let's see what happened, or when we plot the production function, how it looks like. And one of the very important features of this production function is the diminishing returns to capital, which we explained before. So that means, remember, if you double capital, for example, or if you double the amount of capital we use, then output will increase, but it will increase by less than the double. So in that graph we see now, you see that the distance between A, B, so the change of capital on the capital per worker on the horizontal axis, compared to CD, from C to D, again, capital change in capital per worker, these are exactly the same amount. Okay. However, the change on the vertical axis that show the change in output per worker, you will see that the distance between C and D, so that distance is actually smaller than the distance from A and B. So as you add more capital, so basically you suffer, or this sort of production function exhibits diminishing returns to scale diminishing returns to capital. So when you, for example, if you double the amount of capital you use, you would imagine, or would expect, that the amount of output will change by less, and as you add more capital, that will be less and less. So that is the idea. So in that case, we say this production function exhibit diminishing returns to capital. So the extra output from a little bit more of capital decreases as K increases, or as the amount of capital increases. So this could be, as I said, one of the important features of this sort of production function. That's why you see why we plot that production function in that way. So it kind of, the slope, it takes that way, that takes that shape. So it doesn't go that way, or it's not like a straight line where you have the slope is exactly the same at any point on that straight line. But now we have a production function that looks like that, which would show how the slope change as you move across the horizontal axis, or as you add more capital. So in that case, if we look at the slope, for example, here, so the slope of production function decreases as as you add more capital, as you increase your capital. So as you move across the horizontal axis, then the slope of that function decreases. And you can see now how to measure the slope of a production function, because this is a curve. So basically you need to look at the tangent line at each point, because as you all know, the slope of a straight line is constant wherever you are on that straight line. But looking at a curve like the one that we're looking at now in the case of production function, so the slope change from one point to another. So to get the slope at any given point, you just need to look at the slope of that straight line that is tangent, that just touch that point. And as you can see in that graph now, so the slope of the tangent line higher at K1. When we move to K2, that slope then become less. So it's higher at K1 compared to K2. So just by the way, as we are here, so the slope of the production function is basically, again, this production function, you have output per worker on the vertical axis, and you have capital per worker on the horizontal axis. And the slope in that case is the marginal product of capital. So that means the amount by which output increases when you increase capital by a very small amount. So how much gains or how much output you will make, or how much output will increase, that is what is called the marginal product of capital. So declining marginal product of capital suggests that it will be difficult to generate sustained growth simply by increasing K over time. So that is not sustainable. So if you keep increasing capital, and because capital suffers from diminishing returns to capital, so that means as you increase capital, so that means every time you increase capital, you will have output will increase, but will increase by less compared to the previous time. And as you do that more again, so that means it is not sustainable. It's not going to give you the sustainable economic growth by just increasing capital over time, because again, it's just the shape that production function looks like. Again, you saw the slope, how the slope change as you add more capital. So, however, if you compare that, so just going back to what we referred to first, we said for growth to happen, we're looking at two main factors here. One is capital accumulation, so increasing more capital, which implies higher saving rate. And on the other side, you have, or the other determinant is technological progress. So basically, you would have, when you have improvement in technology level. And now, as I said at that point, we said if there's an improvement in technology, or first of all, if there's a change in capital, that means you're moving along the same production function. However, if we're talking about change in technology, that means the production function itself should shift upward if there's an improvement in technology. And that's what we see here. So this to represent an improvement in technology which shift the production function up, and obviously that will lead to an increase in output per worker for any given level of capital per worker. So that is basically, that's what we talk about when we talk about growth. Shifting that production function upward means we have higher output per worker at any given level of capital per worker. So that was very important points that you need to know about the production function, and explaining why it takes that shape, why it looks like that. Again, just don't get lost in the details. Just you need to sit back and just see the whole picture. The whole picture here, we moved from looking at output fluctuations in the short run. Now we are talking about economic growth in the long run, and what determines that growth in the long run. So again, just don't get lost in the details. So what we're talking about here, we're talking about two factors. We talk about capital accumulation, so you have higher saving rate against or versus having an improvement in technology, which basically what it does, it shifts the entire production function upward, which means or which implies that we would have a higher output per worker at any given level of capital per worker.